let's start solving the chapter 3 E1. And a steel ball is dropped from the driving platform with an initial velocity of 0 and using the approximate value of g as 10 meter per second square. And then what is the velocity of the ball 0.8 second after its release? Okay, v equal v naught plus at. So v0 is 0 plus a is 10 meter per second square times 0.8 second. Then 10 times 0.8 become 8 meter per second, and but this is downward because the gravity is always downward. Okay, what is its velocity 1.6 second after its release? v0 plus at. Then 0 plus 10 meter per second square times 1.6 second. Then 16 meter per second, also downward. Okay, so that is your answer. Okay, the E2, the same problem as exercise 1, and through what distance does the ball falls in the first 0.8 second radar? D equal v naught plus v naught t plus half a t square. D naught is 0 and v0 is 0, and then only the last term, which is 10 meter per second square, the 0.8 second square. 0.8 square times 5. 0.8 square times 5. Then 3.2 meter downward. And then how far does it falls in the first 1.6 second of its flight? Now only changing the time. D equal d naught plus v naught t plus half a t square. Then half, this is 0, this 0, and only this 10 meter per second square and 1.6 second square. Then 1.6 square times 5, becoming 12.8 meter. This is your answer. Okay, and the next one should be E3. A large rock is dropped from the top of a high cliff, assuming that air resistance can be ignored, that the acceleration has the constant value of 10 meter per second square. How fast would the rock be traveling 5 seconds after it's dropped? What is the speed in miles per hour? Okay, this velocity equal v0 plus at. v0 is 0 plus a is 10 meter per second square, t is 5 seconds. So your v becoming 50 meter per second. Okay, that 50 meter per second times we convert 1 mile. 1 mile is 1609 meter, and then 1 hour becomes 3016 seconds over 1 hour. Then second cancel, meter cancel, and then 50 times 3600 divided by 1609. Okay, 5 times 3600 divided by 609, and you will get 111.87 mile per hour is your speed for 50 meter per second. Okay, let's solve next one, E4 on chapter 3. Suppose Galileo's pulse rate is 80 beat per minute, and then what is the time in second between the consecutive pulse beats? Okay, 1 minute it has 80 beats, right? So each second 60 seconds equal as 1 minute, right? So every minute 80. So 60 seconds divided by 80 beats, then you will get 60 divided by 80, becoming 0.75 second per beat. Okay, that is your answer. And how far does an object falls in this time that dropped from the rest? Okay, distance equal d naught plus v naught t plus half a t square. This becomes 0, v naught is 0, and then this half times 10 meter per second square times 0.75 second square. 0.75 seconds square times 5, becoming 2.8125 meter. Okay, that is the falling. Okay, thank you. Okay, the next question is E5 on chapter 3, and a ball is thrown downward with the initial velocity of 12 meter per second using approximate value of g 10 meter per second square. What is velocity of the ball 1 second after it is released? Okay, v equal v naught plus at, and v naught is 12 meter per second downward. Okay, downward, and your gravity equal your acceleration, which is 10 meter per second square, which is also downward. Okay, and v0 is 12 meter per second, and your time is 1.0 second, right? Plus a is 10 meter per second square. This is downward 1 second. Then becoming 12 plus 10, becoming 22 meter per second downward. Okay, the downward, or you can put as negative in front of it, and then it's negative direction. Okay, the direction is upward, we call as positive. Downward we call as negative. Down is upward. Okay, so that is our definition. So you can put as a negative 22 meter per second, or you can put as 22 meter per second as downward. That is your answer. Okay. Okay, the next question is, a ball is dropped from the high building using the approximate value of g 10 meter per second. Find the change in velocity between the first and fourth second of its flight. V 1 second, and also we find v 4 second, and then the difference we will find it. V naught plus 80 1 second. Then it's dropped, just free fall, so 0 meter per second, 10 meter per second square. Then t is 1 second, becoming 10 meter per second downward. Then v 4 second. Everything is same. A time is different. 0 plus 10 meter per second square 4 seconds, becoming 40 meter per second. This one also downward. What is the difference between that? V 4 seconds minus V 1 second is difference, delta V, or change of your velocity. Then 40 meter per second minus 10 meter per second, and 30 meter per second difference between that. Okay, let's solve chapter 3E7. A ball is thrown upward with initial velocity of 15 meters per second, and using approximate value of g is 10 meters per second. What is the magnitude and direction of ball's velocity? And 1 second after it's thrown, 2 seconds later. Okay, we already defined upward is positive, downward is negative. Okay, so this says upward, but gravity is always downward, right? So V equal V naught plus AT. Then V0 is upward, thrown upward means 50 meters per second, plus your gravity going negative 10 meters per second square because of negative direction, and 1 second. Then it becomes 15 minus 10, becoming 5 meters per second. This positive means upward. Okay, then the second question, V naught plus AT. 15 meters per second is the same as upward, negative 10 meters per second square as your gravity, 2 seconds. Then 15 minus 20 becomes negative 5 meters per second. The magnitude is 5, and then direction is downward. Okay, downward. So, which means ball is thrown and then coming down. 1 second later, reaching here, and another second, which is 2 seconds. And its ball is coming, passing the high top, and passing certain point. Yep, that is your answer. Okay. Okay, the next question is the same as number 7. How high above the ground in the ball in exercise 7? And then 1 second after it's thrown, and then 2 seconds after it's thrown. Okay, D equal D naught plus V naught T plus half AT square. D naught is 0, and then V naught is 15 meters per second. Then time is 1 second, plus half times negative 10 meters per second square, and time is 1 second square. Then this becoming 15 meter minus 5 meter, then becoming 10 meter above the ground. And 2 seconds later, D equal naught plus V naught T plus AT square. D naught, this is 0. V naught is 15 meters per second. And 2 seconds later, 2 seconds plus half negative 10 meters per second square, and then 2 seconds square. 2 times 2 is 4, 4 divided by 2 is 2, 2 times negative 10 is negative 20 meter, and then this 15 times 2 is 30 meter, then becoming 10 meter. Same height, but direction is opposite direction. Okay. Okay, the next question is at what time does the ball in exercise 7 reach the highest point in its flight? Okay, and use the approximate value of g is 10 meter per second square. And remember that velocity is equal to 0 at the high point. Okay, v equal v naught plus at. The highest point is we call it top. v top equal v naught plus at. That v top is 0 meter per second because it's highest point, it's changing turning point. V naught is 15 meter per second, and plus the gravity, because it's negative 10 meter per second square, because always gravity is going to negative. Find the t. We need to find the t, and then this one going, and then t become 15 meter per sec divided by 10 meter per second square, becoming 1.5 second. At that time, we got the highest point. Okay, and then this is time, and now we need to find the height. D equal t naught plus v naught t plus half a t square. D naught is 0, and then v naught is 15 meter per sec. Time is 1.5 second plus half times negative 10 meter per sec square times 1.5 second square. Okay, 15. Okay, 15 times 1.5 minus 5 times 1.5 square, becoming 11.25 meter above the ground, which is the highest point. Okay, so time is this, and then you need to find the height, then you can find it this way. Okay. Okay, the next question is E3, chapter 3, E10. Suppose that gravitational acceleration on the certain planet is only 3 meter per sec square. A space explorer standing on this planet threw a ball straight upward with initial velocity of 18 meter per second. What is the velocity of the ball 4 seconds after it's thrown, and how much time elapses before the ball reaches the highest point in the flight? Okay, so the velocity equal v naught plus at. Right now, this is your a, this is v naught. Okay, and upward is positive. This gravity is always negative. So 18 meter per second plus negative 3 meter per second square times 4 seconds. Then 18 minus 12 becoming 6 meter per second, which is your velocity at that time. And how much time? Okay, v top equal v naught plus at. Then you need to find the t. V naught is 18 meter second plus a equal negative 3 second square times the t equal 0, because top point is 0 meter per second, and then your t becoming 6 seconds. If you wanna find the height, and then you can t equal d naught plus v naught t plus half a t square. Then d naught is 0 and v naught is 18 meter per second. Then time is 6 seconds plus half times negative 3 meter per second square times 6 square. Then you will get 18 times 6 minus 1.5 times 6 square. Then 54 meter. This is flying while reaching the top. Okay. Okay, let's do the projectile motion, which is E11 on chapter 3. A bullet is fired horizontally with the initial velocity of 900 meter at the target located 150 meter from the rifle. How much time is required for the bullet reach to the target? So the distance is 150 meter away. Velocity equal 900 meter per second. And your time, the velocity, you can calculate distance divided by time, and then you can rearrange t equal d divided by velocity, initial velocity. So your d is 150 meter divided by 900 meter per second. 150 divided by 900, then 0.167 second. Okay, using approximate value of g is negative 10 meter per second square, how far does the bullet fall at this time? Okay, d equal d naught plus half v0t plus half at square, v naught t, right? But this v naught is vertical, v naught vertical. So this is 0, this is 0, as well. Only it affects here as acceleration or by gravity. Negative 10 meter per second square times 0.167 square second square. Square times 5. Then 0.139 meter as negative means it's going down. So which means your bullet shoot and then your target is passing this way, and then this height is 0.139 meter, which is about 14 centimeter. 14 centimeter down. That is your answer. Okay. Okay. Chapter 3, E12. A ball is rolled up shelves with a horizontal velocity of 6 meter per second. And what horizontal distance on the shelf does the ball when if it takes 0.4 second to reach the floor. Okay, so this is shelf, and then originally this horizontal velocity 6 meter per second, and then is drop and reach to the ground after t equals 0.4 second. So you need to find the distance between them. Okay, distance. The distance equal d naught plus v naught t plus half at square. This is a horizontal direction. So horizontal direction doesn't have acceleration. This is become 0. This 0. So horizontal velocity times the t, which is 6 meter per second, times t is 0.4 second. Then 2.4 meter away from the table shelf. Okay. Okay. Let's solve chapter 3 E13. A ball roll up table with a horizontal velocity of 4 meter, and it takes 0.5 seconds for the ball to reach the floor. How high is the floor from the tabletop? Okay. So at this moment, you need to height find the height is v naught equal 4 meter per second. And then your trajectory, like that, fall down, right? And then you need to, not the distance, is the height. You need to distance in vertical. This is horizontal, right? Vertical distance, d equal d naught plus v naught t plus half a t square. This is vertical, and then this become vertical, this become vertical, and this vertical side, right? So vertical distance is 0, and the vertical velocity, this is the horizontal velocity of 4 meter per second. So vertical velocity becomes 0 too. And all it is half negative 10 meter per second square times t equal 0.5 second square. Okay, 0.5 square times 5 become negative 1.25 meter. This we put as 0, and then going down, which is 1.25 meter going down. Okay, that's why it's negative 1.25 meter. Okay. Okay, the next question is about the roll-up table, horizontal velocity 5 meter per second. It takes 0.6 seconds to reach the floor. What is the vertical component of ball's velocity just before it hits the floor? Okay, v vertical equal v not vertical plus at. Okay. V vertical is 0, only it has a horizontal, so which means negative 10 meter per second square times your 0.6 second, then negative 6 meter per second. The negative means going downward. Okay, what is horizontal component of ball velocity just before it hits the floor? Horizontal and v not horizontal plus a t. This a is horizontal acceleration. This is become 0, so this 5 meter per second is v horizontal on the floor. That's it. Okay. Okay, the next question is a ball rolls up a platform that is 5 meters above the ground. The ball's horizontal velocity as it leaves the platform is 6 meters per second, which is v not horizontal. The d vertical, right? And how much does it takes the ball hit the ground? Okay. D vertical equal D 0 vertical plus V 0 vertical plus half A vertical times the T square. And you need to find the T. Okay. So we only knows D not vertical 0, put 0, and this as 0, and only this and this dv we know it, 5 meter equal half times negative 10 meter per sec square times the t square. This 5 is we put our reference put this as 0, and then this becoming negative 5 meter, so we can put as negative 5, and then you will get t as 1 second after your calculation. Okay, and how far from the base of the platform does the ball hit the ground, which means its ball is how far to the ground, which is V naught is horizontal is 6 meter per second. So D horizontal is D0 horizontal plus V0 horizontal plus half A horizontal T squared. This is 0 and this is 0 times T. V naught is 6 meter per second, 6 meter per second, and the time is 1 second to travel, which is 6 meter away. So D horizontal equals 6 meter. D horizontal. Okay. Okay, let's do the last question on the chapter 3. E16. A projectile is fired at the angle such as that the vertical component of its velocity and the horizontal component of velocity are both equal 30 meters per second. And using approximate value of g equal 10 meters per second square, how long does it take for the ball to reach the highest point? Okay, the v vertical v0 vertical equals 30 meters per second. V0 horizontal equals also 30 meters per second. Right? So V top equal V0 vertical plus AT. V top equal 0 and V0 vertical is 30 meters per second plus A is negative 10 meters per second square. And this is T. So after you calculate, T equals 3 seconds to reach the top. Okay, what is the horizontal distance does the ball travel in this time? So in this case, the ball is travel. This is top point. This is top, which is T top equal 3 seconds. And to coming back on the ground, you need to another 3 seconds. This is up to here 3 seconds. And then altogether, distance could be horizontal equal D0 horizontal plus V0 horizontal T plus half A horizontal T squared. This horizontal acceleration is 0. This horizontal distance is 0. So V0 H equal 30 meters per second. And the time could be 3 times 2 becomes 6 seconds. Then 180 meter travel for this projectile motion. Okay, thank you.